If you've been following this project from the very beginning, you probably remember where we started. We started with an empty piece of land, then the setting out, the excavation, the trenches, and eventually one of the biggest challenges on this project is dealing with the different foundation depths. So after all that excavation, we finally reached the stage where things start to get exciting. The trenches, they were fumigated and the footing was done. Then we gave it time to cure, and now we proceeded to the box of the foundation. But this wasn't just a simple foundation, this is a stepped foundation, meaning the depth changes in different sections depending on the level of the land and the requirements of the design. So our shallowest point, it was 1.2 meters. So in today's video, I'm taking you through everything that happened, from the footings to building the box, backfilling, compaction, water application, plumbing, electrical installation, and finally pouring of the slab. So if you're planning to build your house in Zimbabwe, you really need to pay close attention, because some of the most important work in a house is the work that eventually gets buried and disappears. That is the foundation itself. Okay, so as you can see in the video, the works of the bulk have already started. So it can sometimes look like everything happens very quickly, like the bricks they're already coming up, the workers they're on site, the walls they're now coming up, but there's actually quite a lot of planning that happens behind the scene. So on this project, as you can see, we have manpower today. So this is according to the time frame in which we wanted to get the box completed. So because of that, the manpower had to be adjusted accordingly. And when we had activities that required fewer people, we didn't have to have so much people on site. So the brickwork for the box took us 2 days, and because this is a step foundation, you can actually see that the levels, they aren't all the same exactly. So the foundation follows the design and the levels of the site. Our minimum depth, it was 1.2 meters, but there were areas where they were deeper. So this is something that is very important for anyone building on land that isn't perfectly level. You can always assume that the entire foundation will be at one uniform depth. The design and the ground conditions are the ones that actually determines what happens. So this is exactly what we talk about when we say, when you're building, you are not simply looking at what your neighbor has used and how much they have used on the foundation, because the conditions, they are not always the same. So the foundation requirements depend on the design, the site conditions, the soil, and the structural requirements of the particular building. So while we are laying the bricks, we are also following the levels required for this particular house. And slowly the box begins to take shape. At this point, we're still quite far away from seeing a house, but underneath this foundation is where the story of the house really begins. As you can see, we are making use of our tools to make sure that the build is straight, the corners are straight. So you can actually see that we have our corners there, and then we have our twine, which we are using, as well as other tools and equipment that we use to make sure that in terms of the measurements and everything, we are going according to the plan. So now we are rounding off the box. So for those that saw the previous episodes, you'll notice just how deep some of these areas are. The depth is going to become very important in the next stage, because now that the box is complete, we need to start making preparations for the backfilling. And when I say fill it, I'm talking about lots of materials, that is the rubble. Remember, this is a deep foundation box, so we're going to need a significant amount of rubble for the backfilling. And this is where the rubble that we generated during the excavation, as well as the rubble that was already on site, becomes very useful. So for those that saw the video where we were asking people to come and take rubble, we had lots and lots of rubble. It looked like we were actually collecting rubble from the entire neighborhood. But now, as you can see, we have a very good use for it. So our box is now complete, and we are now moving to the backfilling. So for the backfilling, this time, as usual, we brought in a machine. So I know someone will be asking, why use a machine for backfilling? Can't this be done manually? Of course, it can be done manually, but remember, we are managing a construction project, and time is also a resource. So this foundation box is deep. There's a significant volume of material that needs to be moved, and if we tried to do all this manually, we would spend a lot more time, and we would need significantly more labor. So for this particular activity, using machinery, it made sense. And this is something that I always encourage people to consider when building. Don't just ask, how much does the machine cost? Ask, how much time is this machine going to save me? Because sometimes paying for machinery can actually save you money overall. It can reduce the number of labor days that are required and help you maintain your program. And on a construction project, delays can always become very expensive. So we brought in the machine and started filling up the box. There we have it. It is moving around, doing what it has to do. Alright, as you can see, for the rubble, we are actually going for the rubble which is far, leaving the one which is nearby. And I know someone is already wondering, why are we taking rubble from that pile when there's another pile that is so much closer to the house? Obviously, it would seem logical to simply take the closest rubble, but construction isn't always about what's closest to me. It's about what is suitable for that particular activity. The pile that was closer to the house contained a significant amount of soil compared to the rubble, and the other pile had a better ratio for what we needed. So for this backfilling operation, we wanted material that would give us the stability we were looking for once properly placed and compacted. So even though one pile was closer, it wasn't necessarily the better choice. And this is something that I want people who are building to understand. Sometimes you'll see your contractor moving materials that appears to be the wrong place. Don't immediately assume they are just wasting. Ask the question, why are they doing that? Because the location of the material isn't necessarily the most important thing. The properties and stability for the work are. Of course, material selection should always be based on the project requirements and specifications, and that's exactly what we were considering Yeah. As the machine continues working, you can start appreciating just how much material is required. And this is one of the reasons why I say that the foundation stage can consume a surprising amount of time and resources. From the outside, you might look at the fish house and never realize what is underneath it. You don't see the excavation, you don't see the material that had to be removed, you don't see the rubble being sorted, you don't see the backfilling, and you definitely don't see the compaction. But all of that work is happening before the first brick of the superstructure even goes up. And that's why I decided to document this project from the beginning to the end, so that those that are building, especially their very first houses, or those that are even still in the stages of buying their residential stand, you get to see and appreciate the stages so that you know the sequence, what starts first, etc. as you go. So, because I want somebody watching from, it could be Zimbabwe, South, UK, Australia, America, Dubai, anywhere in the diaspora, to understand what actually happens when you're building your house back home. You might be sending money every month, you might be receiving WhatsApp updates saying we're done with the foundation, but what does that actually mean? What happened? What did they use? How deep was it? How was it compacted? What happened before the slab? These are the things that matter, and that's what we're showing you in this video. So with all the rubble that is getting in the box, just imagine if we had to do it manually. How many days was it going to take us? How many days? Maybe it was going to take us 5 to 7 days, or even more. Just imagine or picture people moving in with their wheelbarrows to go to that pile, load their wheelbarrows, come back and put them in the box, do that countless times. I'm sure this was going to take a very long time. And then for the machine, as you can clearly see, this is a machine and it's quite different from human work in terms of neatness, or are there any walls that face to be distorted a bit? Well, yes, there was a line that got disturbed, not the whole line, but just a few bricks, but then we later on fixed them after we were done with the backfilling. But in terms of comparison, depending with the size and nature as well as time considerations for your projects, we saw it was better to go with the machine. So with the machine, how long did it take us to get the work done? So we took 3 hours, 20 minutes. That was the time that we took to get the backfilling done. So in terms of time, this is very fair, because if you are to do a comparison, 3 hours, 20 minutes versus 5-7 days, that's a lot of time, of which for us, like I mentioned before, time is a very important factor for us. Okay, so this was like the last 30 minutes and we're just rounding up on the backfilling. We were almost done with the levels that we wanted, so the rest of it we were going to finish manually after this. So here we're just around up on the backfilling. Yeah, as you can see, some of the rubble is quite heavy. It was nearly impossible for people to be lifting such kinds of rubble. So now we're moving on to the next stage, which is the compaction, which we are going to be doing in 2 stages. So we compacted approximately halfway through the backfilling, then we completed the remaining filling and compacted again. But why not simply just fill everything and compact at once? Here's the thing, when you're dealing with a deep layer of fill, you want the compaction effort to reach the material in layers. So if you fill a very deep box and only compact the top, you cannot expect the same level of compaction throughout the entire depth. So that is why we're doing it in stages. And for this, we are using a jumping jack compactor. And now moving on to the next stage, which is the water application. This is how the water from the hose pipe was coming out like. So obviously we wouldn't go in with such kind of water pressure. So we had to bring in external water to come and do the water application for us. Because just imagine if we were going to use the hose pipe, how many days was it going to take us to apply water to every part of this house? It would take a very long time. So we brought in the water. So the amount of water that we used for this whole box combined, the water that we bought and the one that we used from the hose pipe, we used 20,000 liters of water. And maybe for those that are wondering, why do we even need water when we are compacting our rubble? Moisture plays an important role in achieving effective compaction. So when the soil and the granular material have an appropriate amount of moisture, the water holds the particles move and rearrange under the action of the compactor. So the particles can packed closer together, reducing the amount of air voids. That means we can achieve a denser and more stable layer. But here's the important part. More water doesn't automatically mean better compaction. You need the right moisture condition. Too little moisture can make compaction difficult. Too much water can also create problems and prevent the material from compacting properly. So we're not simply pouring water because we just have to put water. We are applying it as part of the compaction process. And because of the volume of material we're dealing with, bringing in additional water allowed us to complete the work much more efficiently. So as you can see, we are doing the water application, and yeah, it's going on very well. We can see they are applying every corner, every box. The moisture is introduced, and the compaction, it will go very well, and gradually the foundation box, it will begin to disappear beneath the fill. So this is one of those stages where you can really see the difference between construction as a hobby and construction as a properly managed project, because everything has to go in sync. Every stage has to be fully prepared for. You can't say, oh yeah, I forgot this, and you already have manpower on ground and you say, oh no, I forgot. Then it means you are losing money. Yes, because every minute you have manpower on your site, it means they are going to be paid. So you have to think about sequencing, you have to think about the resources, you have to think about the time, you have to think about the quality, and you have to think about what is coming next. Because we are not just filling this box for the sake of filling it. We are preparing a stable base for the slab that will eventually sit above it. Yeah, so as we're progressing, this is what our work was looking like. Yeah, as you can see, now we have main power that are just trying to level out the box. As you can see, or as you saw, the machine, it did what it did, but people had to make sure that there's even distribution. And this is how our box was looking like after everything was done and the compaction was done. This is how our box looks like. As I said, this is a step foundation, so that is the reason behind the layers that you can see here. And then we had to call in the city operator inspector to come and inspect our work, and it's passed. So after the inspection, we moved on to the next stage. We installed the black plastic, and then we put the mesh reinforcement, and along that we laid out the plumbing and electrical pipes that needed to go within the slab area. So this is another stage where coordination is extremely important, because once the concrete is poured, accessing these pipes is going to be very difficult. So everything needs to be properly positioned before the concrete arrives. And as you can see, we are now pouring in the concrete. So as you can see, we have our team which is placing it, and you will notice that we also have a poker vibrator. So concrete can contain trapped air when it is placed. If that air remains in the concrete, it can create voids and reduce the quality of the finished concrete. So the poker helps to consolidate the concrete and remove trapped air. It also helps flow around the reinforcement and into the spaces that need to be filled. So the objective here is to achieve a properly consolidated and homogeneous concrete slab. And again, this is why having people who understand what they're doing on site matters. So concrete pouring isn't simply about mixing concrete and throwing it onto the floor. It's a process, it's a sequencing, placement, compaction, and the finishing itself. So here we are. This is what our final result of slab looks like. And when you look at this now, it might look just simple, just a concrete floor, but think about everything that happened that you saw. We started with the excavation, etc., till we got to this stage. Thank you so much, guys, for watching. Don't forget to like, comment, share, and subscribe to this channel. Until next stage.